But then in the write up I talk about something called after state. I just wanted to mention that very quickly. So what is an after state? It is a very interesting concept. Yeah. What is an after state?
It goes to the after state.
Yeah. So in many problem instances, especially things like games or like this kind of civil, I mean like a system where there is moves by nature, right. So there are moves by the human, moves by nature or moves by an opponent, right. So that is the whole stochasticity in the system is introduced either by this opponent or by nature, right. Your actions, the effects of your actions on the system are deterministic, right, but you do not know what the opponent will do, right. So in this case of nature is like cows aging and things like that. So your action is selling cows, that is deterministic. If you sell a cow, the cow is gone from you, right, you know that effect, right. You make a move, then the piece moves, right, there is no stochasticity there, right. When I want to move a pawn on the board, I put it there, well, as long as you do not have Parkinson's or something, okay, it will actually land up in the square that you wanted to go, right. And well, you have to consider all eventualities, right. But then you do not know what the opponent is going to do, right. So if you look at the actual state transition dynamics, it is going to look stochastic, but there is a deterministic component and then there is a stochastic component. So sometimes it makes it a lot more convenient to come up with a solution if you pull out the deterministic component separately and represent S cross A as an after state, right. So what is an after state? It is in some sense you take your S, right, you apply A to it, right. So you get to some other space which we will call S prime, okay, and now all your stochasticity is applied to a state in S prime, right, and this will result in a state in yes, right. So this is essentially what is happening. So S cross A to S prime to S, okay. So if I am going to represent things as after states, instead of learning a Q function, I can learn a value over the elements in after states. I can learn a V function over the entries in S prime. This is essentially a combination of S cross A. So the V function over S prime is almost like learning a Q function. And what is the advantage of learning this V function over S prime instead of Q over S cross A?
You have one less dimension.
I have one less dimension and anything else? One less dimension, okay, then I explained that in the write up.
Can you reuse it like other state?
So it could be that many state action pairs yield the same S prime, right. I actually talked about this very briefly talking about tic-tac-toe. I told you there are many different ways in which you could have come here, right. So I do not care which way you got there, right. I could have, for example, I could have from there I could go there, right, or from I could go there, right. So this is a state and the action was put across there, and this is the state, the action was put across here, but both had the same after state. And since the evolution from here is going to be the same, this is an after state, right, this is a state, this is an after state, right. So you see why I denoted the after state by S prime, why? In tic-tac-toe, S is going to have an equal number of X's and O's. S prime will have one X more than O, right. If I am playing X, whenever I see the board, whenever I have to make a move, there will be equal number of X and O's, right, but an after state will have one X more than O, right. So it is actually a different set of states, they are not really states. I mean I might or might not see them in reality. For example, in the cow task, after states are possibly states, I mean cannot be states, is it? They are also states, right? They are also states. After states are also states, but in tic-tac-toe case, after states are not states, right? Because you will never see a state that has a more x's than o's. Right, so that's why I denoted this as S prime, as a separate thing. It could be the same as S, but it could also be different. But the point here was, this is actually a QSA, right? I mean, if I learn a value function over the states, it's QSA, and since the whole thing is deterministic, if I know the rules of the game, I can do the look ahead. So I give you a state, I look at all possible after states, and then I pick an action which leads me to the best possible after state. I can do the look ahead because it is only the application of the action. I do not have to model nature, right? I only have to model what happens when I apply my action to it. So it is a plausible look ahead, okay. And this is how Jerry Tesoro implemented his backgammon also. He did not learn a value function over state actions, he learnt a value function over after states, right? Backgammon also, right? Once the die roll is determined, right, you take an action, right? When you take an action, your state includes the die roll, right? And once you know the die roll, then whatever action you do, the effects will be deterministic, and then your opponent will actually make a non-deterministic move. So that is fine. Okay. So any questions? Okay. So that brings us to the end of chapter 6. So at some point, I will do some proof sketches for TD0 and possibly Q learning. But it might not be next week, we will see. And so next I will start off on chapter 7.